Hello, 8th graders, and welcome to our last official lesson. We are on Unit 9, and your last lesson in Unit 9 is this 10.7, which is operations with scientific notation. So what we're going to do is we are going to be doing different operations with scientific notation, so things like addition, subtraction, multiplication, division, and using some of those um, exponent rules as well as we go through, okay? So your I can for today, there's only one, is I can add, subtract, multiply, and divide numbers written in scientific notation. All right, don't worry about warm up. We're not going to worry about it. All right, so your essential question is how can you perform operations with numbers written in scientific notation? So again, that's scientific notation. So like I had mentioned, we are going to be using some of those exponent rules as well when we go through this. And so you're going to see how we can add things in scientific notation, subtract them, as well as multiply and divide them using some of those integer rules, or so those not integer rules, exponent rules, and so on, as well as using our basic knowledge of addition, subtraction, multiplication, and division. All right, so there's no key idea for this, so we're just going to jump right into it, and we're going to do some examples to see, to show you how to do these. So the first example is all about your sum or your difference. Remember that your sum is your addition, your difference is your subtraction. So my direction is find the sum or difference. Write your answer in scientific notation, okay? So again, we want to make sure that these are stated in scientific notation. Remember, when we're talking about scientific notation, you need to have an integer that's between 1 and 10. So both of these look good on this case. Same with these ones. And it's going to be multiplied by 10 to some sort of power. And the power can be negative or the power can be positive. So we're going to go ahead and take a look at this first example. So I've got 4.6 times 10 to the third plus 8.72 times 10 to the third. Now we are lucky in this case because as you notice, the powers are the same, okay? When the powers are the same here, it's actually fairly easy. I'm just going to go through and add my integers as I normally would, okay? So my power still is going to stay as 10 to the third for right now. Now there's going to be a case where we may need to change it, and you will see why in a minute. So I'm just going to go ahead and grab my calculator. I'm just using my cell phone today. You can add it along with me, 4.6 plus then 8.72. So this gives me 13.32. I did get my little pad thing here, writing pad, but I'm still not used to using it, so sorry if it's written a little sloppy. So with that though, the thing that happened here is that although we were able to keep this to the 10 to the power of 3, we now run into the issue where this number is not making my whole form in scientific notation. Because remember, I can only have integers between 1 and 10. And this is 13.32. So this does not work leaving it like this, okay? So what I'm going to have to do is I'm going to have to move the decimal one place over to the left. So it's going to be 1.332. Now, if it's easier for you to visualize this, I would suggest figuring out what this is, okay? So if this was 13.32, that means you're going to move the decimal 3 places over. So that would be the same as 3320. So ultimately, when I rewrite this in scientific notation, I want the answer to still be that. So I'm still going to have 10 to the power, and then we're going to figure out the power. So how many times would I have to move my decimal over so that I get this exact same number? 1, 2, 3, 4. I need to make this now into an exponent of 4. And now I have it in scientific notation. Okay? So again, you're going to move it over if you need to. Maybe you need to move it backwards. It depends on if you get numbers that are smaller or numbers that are bigger. Visualizing it out, it might be easier to write it out in what it really would be, and then figuring out from here how you would set this up. Okay? Same thing would apply if you're doing an operation with subtraction if they have the same power of 10 here. In this case, though, I have a different power of 10, okay? So whether it's or you're adding or you're subtracting, here's what you're going to do when they are different powers, okay? For adding and subtracting, they have to be in the same power. With multiplication or division, I can easily use my exponent rules to figure these out without having to do an extra step. But we cannot do that with addition or subtraction. So what I need to do is I either need to convert this 10 to the negative 2 into 10 to the negative 3, or we're going to convert this one to 10 to the negative 2. Thinking about this, let's see. So we're going to change this one into a 10 to the negative 2 power. So basically what's going to happen is I'm going to have to move this decimal 1 over, because remember, if it's negative, I'm going to move them over this way. And since I am going to reduce this amount, I'm going to move it 1 more over. So now instead of having 6.6, I'm going to have 0.66 times 10 to the negative 2. All right, so now that they're both in the same form here, what I can do is I'm just going to subtract my integers. So I'm going to take that 3.5 and subtract the 0.66. So it looks to be that I get an answer of 2.84. And hey, that's already in your scientific notation form, because I need it between 1 and 10. So we don't have to do like last time where we had to do that extra step at the end. We're good now. And so then I'm just going to multiply it by 10 to the negative 2. And that is my final solution. Okay. Again, it is hard deciding which one to move over. In case it's a subtraction, I would suggest always that what you're subtracting or here. So that second number, change that one to match the first one. I think that's going to be easier in that case. And so all I did is just move a 1 over to the left and reduce this amount. Okay. And same thing would apply for addition if they're in different varieties here. So different powers of 10. Let's keep going. All right, so I want you to try and do these ones on your own. This time they basically flipped it. So last time we had an addition where the powers are the same, and we had a subtraction where the powers were different. This time you have an addition where the powers are different, and this one you have a subtraction where the powers are the same. Okay, so same rules apply. Make sure you have them in the same power first, then you can add the integers depending on what the operation is, or you're subtracting them. And then make sure that they're still in scientific notation form, all right? Because it says we need to write them in scientific notation. So go ahead, pause the video. I want you to try these out. When you get back, I'll go through the answers and explain my reasoning. This probably is one of the trickier lessons of this unit. So feel free to always go back through this video if you need more help in practice. When you get to your big ideas, go ahead and make sure that you are using that check your answer feature or even that need help button, because they have videos you can watch, things you can read to relearn. But as always, you can reach out to me too if you're really still stuck. We can set up a Zoom meeting. I can send you additional resources. I'm always here to help. So go ahead, try these though first, and then we will come back and I will give you your answers. Alrighty, welcome back. So here is what I did to solve out these problems. Just like last time when we had a subtraction problem and you had powers to different tens, or powers of 10, I switched that second one. So I did the same thing with this one just because of the numbers here. So basically I converted this to 10 to the 2 power. So what I did is just move my decimal over. I moved it a distance of 3 because from -1 to 2, if you were to set up a number line, that's a distance of 3. Because here, hold on. Ooh. -1, 0, 1, 2. Okay, so you're going 1, 2, 3. So I moved it 3 to the left, so I get 0.00341 times 10 to the second. I just then add my two constants and then keep it as the same power of 10. 2 is a lot easier. Again, you just have to subtract your constants. So I'm taking 7.8 minus 4.5. That's how I get my 3.3. And since the powers are the same, I didn't have to change them. It's just going to stay as a times 10 to the negative fifth. Okay? Let's keep rolling. We got lots to do in this lesson. All right, so this one, example 2. This is where I think that multiplication and division within here are a little easier because I get to use those exponent rules that we know about. So we need to take 3 times 10 to the negative fifth times 5 times 10 to the negative second. I want to write this in scientific notation. So here's how I'm going to do this to break this up, okay? It's, in a way, you could kind of think about it as a distributing, but we're not distributing both of these. What I'm doing is I'm just going to take the constants and multiply those, and I'm going to take the powers and multiply those. So it's going to look something kind of like this, 3 times 5, okay, which is also then going to be times by 10 to the negative fifth times 10 to the negative 2. So we know how to do 3 times 5. 3 times 5 is 15 times then. And I know right now this is larger than 10. Your mind might be going, oh no, Miss Wink, it's bigger than 10. Don't worry about it till the end. I want to know what this power is first, and then I will readjust this so it's in scientific notation. So then when I use my exponent rules, remember when they have the same base, so they both have 10, and I'm multiplying them, what I do with my powers then is I add them. So I'm going to add negative 5 and negative 2. Negative 5 plus negative 2 is negative 7. So now I'm going to have 10 to the negative 7. Okay. So what I'm going to actually do in this case is I want to move my decimal so that it's 1.5. So I'm going to move my decimal 1 over to the left. 1.5. And in this case, what I would want to do with this one is that I'm going to add in an extra power. Okay? Because it would be negative if I continued over to negative 7. That's how many I would have to move over. When I really want my decimal here, I'm going to just add in an extra 1. So really, it's only going to be a negative 6 power. So here is my final solution. 1.5 times 10 to the negative 6. Again, it might be easy if you actually plug this in a calculator and be like, okay, 15 times 10 to the negative 7. What's this answer? Does this also match up? Okay, that's another way you can double check your work and see if you're getting it correctly is by using that calculator. Now, if you get too far in with the calculator, especially like, I don't know how good the phone calculators are going to be, they're going to just write it in scientific notation because even the calculators don't want to write out that many zeros or that many digits. So you're going to have to be kind of careful, or you're going to have to be able to handwrite it out as well. Let's see if we can fit this in this time. So we are going to find the answer to this problem. Write your answer in scientific notation. So this time we are given a problem and we want to divide them. So again, we're going to take it step by step by looking at the integer as well as then the powers. So 1.5, so really I'm going to do something like 1.5 divided by 6 times then 10 to the negative 8th divided by 10 to the 7th. All right. You can go ahead and see if you can solve this here. I'm just running out of time for this video, so I will catch you in video 2 and we will finish out this example as well as the rest of the lesson. We may have already said the code word, I may have not. You got to be listening and checking. So I will catch you in part 2. I'll see you then.